Welcome to G Fun Facts Online, where we dive deep into the wonders of science. Today, we're traveling back in time, but we're not looking for dinosaurs. Instead, picture a world of murky prehistoric swamps. Lurking beneath the surface are giants, but not the kind you're thinking of. We're talking about colossal amphibians, some the size of a small car. Imagine a salamander so big it could look you in the eye. It's a mind-boggling thought. But these creatures were very real. The big question is, how did these mega-amphibians become the apex predators of their world? What kind of incredible engineering was hiding inside their powerful jaws? Well, paleontologists have found a way to become virtual bioengineers, and today, we're going to build the bite of a giant salamander. So, how do you test the bite force of an animal that's been dead for millions of years? You can't exactly ask it to chomp down on a sensor. The secret lies in a tool borrowed from the world of engineering, Finite Element Analysis, or FEA. This is the same technology engineers use to test the structural integrity of bridges and airplanes before they're even built. Scientists create a super detailed 3D model of a fossilized skull using CT scans. Then, this digital skull is broken down into millions of tiny pieces or elements. By applying virtual forces, simulating the pull of powerful jaw muscles, they can see exactly how stress flows through the skull during a bite. It's like a digital crash test for a prehistoric predator, and it lets us understand how they hunted without risking any damage to these priceless fossils. Let's look at a couple of these ancient giants. First up is Metoposaurus, a 10-foot-long amphibian from the late Triassic. It had a massive, flat, almost toilet seat-shaped head, with its eyes perched right on top. For years, we thought it was a classic ambush predator, lying perfectly still on the riverbed, waiting for a fish to swim by before snapping its jaws shut in a powerful, straight-on bite. And the FEA models confirmed this was a very efficient way for it to hunt. But then, the computer simulations revealed a surprise. The Metoposaurus skull could also handle the stress of a powerful sideways strike. This wasn't just a sit-and-wait predator. It was a versatile hunter that could actively attack prey from the side. It was a game-changer, revealing a much more dynamic animal than we ever imagined. Then there's the true behemoth, Prionosuchus. This absolute unit stretched up to 9 meters long, making it one of the largest amphibians to ever exist. Its most incredible feature was a long, incredibly slender snout, almost identical to that of a modern gharial, a type of crocodile. This shape is a dead giveaway for its diet, fish. That long, thin jaw could slice through the water with minimal resistance, allowing it to snap shut with incredible speed to snatch fast-moving prey. It was a specialized fish trapper, a totally different hunting strategy from the robust, all-purpose jaws of Metoposaurus. To double-check these digital reconstructions, scientists often look at living relatives. Enter the Chinese giant salamander, the largest amphibian alive today. By studying it, we get a living window into the past. FEA studies on these modern giants show a fascinating two-step hunting process. First, they perform a quick, asymmetrical strike to the side to grab their prey. Then, once they have a grip, they maneuver the meal to the front of their jaws for a much more powerful, crushing bite to finish the job. It's highly likely that their ancient, car-sized cousins used a similar capture and crush technique. So, if these amphibians were so successful, where did they all go? Their reign began to end during the Triassic period, right as the first crocodilians started to appear. While they might seem similar, biomechanical analysis shows subtle but crucial differences. The giant amphibians, for instance, lacked a secondary palate, a bony structure that separates the mouth from the nasal cavity. This and other small architectural differences may have given early crocodiles a competitive edge, allowing them to eventually outcompete the amphibian giants. By merging cutting-edge engineering with classic paleontology, we can resurrect these lost worlds in stunning detail. The jaws of the giant salamanders, from the versatile skull of Metoposaurus to the specialized fish trap of Prionosuchus, show just how diverse and incredible life can be. They're a powerful reminder that the Age of Giants wasn't just about dinosaurs. It was also about the colossal, car-sized amphibians that ruled the waters below.